by popular request, a video about a device that appeared on my bench in another video. So this is something that was suggested a while ago by someone, can't quite remember who it was, but they pointed me to an AliExpress listing and it was for this device. And initially I wasn't overly taken by it, but then I thought, oh, you know what the heck, let's get one and try it out. And it's based on the base unit for a vapour producing device. And it's not a new thing because you've got these USB solder irons and you've got these ones that are based on other vapour producing devices. This one's notable for having a little knob at the back. You can actually turn the voltage up and therefore kind of adjust the power. But what it is, it's got a soldering iron tip, as you'd find in these, but just running off these rechargeable battery banks. So this one came with a roll of solder, which is probably lead free, so I'm not going to use that. It's not needed, we don't need that at all. And it came with 3 bits. It came with the traditional pointy bit that they always seem to supply these things with. It came with a knife bit, which I've never really found a use for, but it came rather unexpectedly, and you can see this is one I've been using. It came with a chisel bit, with a fairly large tip. I think it's about a 3mm chisel bit. So let me screw this in, and I shall show you it in operation. So I found that to use this, it's best to angle it round. I've just gone way too far there. Angle it around so that when you're holding the button, the flat side of the chisel is pointing over to the solder joint. It is locked. So initially, you have to press the button 5 times. 1, 2, 3, 4, 5. And then it likes to show it's running. And then when you press the button, it does the same sort of thing as these sort of vapour devices do. And if you hold the button in too long, if you hold it in for about, say, about 10 seconds, it will cut off. It will go into its standby mode after flashing the LEDs. But by that time, it will be quite hot anyway. So the idea of using these is that because it's based on that vapour device, you have to keep pushing the button and just every so often release the button and press it again. But this is good because it means it doesn't just run all the time, and that conserves the battery. It heats very quickly and it also protects the tip. The tip of this one gets very hot, I have to say. So let's zoom down a bit, just a little bit, not too much, and I shall focus down onto there. Should have done that because I'm going to be holding this up here. No, I shall solder it down there. So let's give this a go. So I shall cycle the button until it comes up to a temperature the solder starts melting. It heats very quickly. And then I shall attempt to solder these connections, which I've mounted some resistors with sticky tape. So you have to get into the habit of releasing and pressing the button and also learning to kind of regulate it, although you can't really see what temperature the tip is at. But once you've actually been using it for a while, it kind of becomes intuitive. The tip can get very, very hot. And it holds the heat for a while. So typically between joints, I'll just let go of the button and then just press the button again before I go into the next joint. And so far, so good. These, incidentally, are little circuit boards for converting a USB cable to drive some standard strings of parallel LEDs. Or whatever you want, actually. So that's them soldered. It went quite well. Now, let's crop these leads. And I shall solder in the matching connectors and we'll see how it deals with the bigger ones. I missed one of those connections, not to worry. I shall get it. Next time round, I shall crop it roughly to length and then I shall flow solder onto that. That's because the lighting is from that direction. I'm looking from this direction. So these are little USB connectors. I'm going to open this up, by the way, and we'll take a look inside it. I just thought I'd mention that. So you can fast forward if you want to the bit where I open it up if you don't want to see me testing its soldering abilities. Oh, these little connectors, by the way. I got a pack of them a while ago from AliExpress and they did not turn up, and I just gave up and ordered them from other suppliers and they did turn up with other suppliers. The packet these came in just arrived today, and it was posted on the 15th of July 2021, and it arrived almost exactly 4 months later. But the tracking on it showed it actually arriving in the UK on the 19th of July. So if that tracking was true, and you can't always trust the tracking from some sellers, then it spent a lot of time with Royal Mail or Isle of Man post. I wonder if it's been affected by a little scandal that happened recently in the neighbourhood when a postal person was found with lots and lots of post in their house. Naughty postal person. Right, tell you what, let's heat this up again so you'll see how fast it heats up. So push the button, release the button, push the button again, just to keep it cycling. There's the solder melting. So not that bad. And once it's hot, it kind of holds that heat for a decent length of time. So let's flow the terminal connections here. Remembering to release the button every so often. Although you tend to do it, as I say, you tend to just do it between solder joints. I wouldn't recommend this solder iron for soldering entire circuit boards, like I'm doing right now, but maybe just tiny circuit boards then. But as I'll show you later, it could actually be a very useful soldering iron for travelling technicians who might suddenly and unexpectedly need a soldering iron and already have the aforementioned vapour producing device. If you wonder why I'm being very cautious about saying vapour producing device, it's because YouTube frowns on the base unit I've got here in its original intended purpose. That is soldering really well. Now I've got one more solder connection to do. That was that one. Okay, and now I shall put these on. These are two little Molex-y type connectors. I say Molex-A because they're not actually Molex. Although Molex makes them, these are a sort of industry standard connector made by various companies. But the first ones I used were Molex, and it just kind of sticks, and I just know of them as Molex connectors. In reality, a Molex connector could be just about anything because they do make quite a lot of connectors. Okay, on goes the soldering iron again. Let's see how fast it recovers this time. Given that didn't take too long, it's already melting. So I shall melt some solder on, I shall flick it off, and then I shall flow it. And it does a pretty good job. It's not bad at all. Releases button and re-clicks button. And that's quite big solder joints as well. If I sound impressed, it's because I am fairly impressed. There, that's praise from Big Clav, is it not? Just like when I tried the original USB iron, I was just blown away by just how good it was, even if it didn't have any fancy thermal regulation. See, that's two little circuit boards made. Now I can snap those apart. So I'll take those two outer ones off and snap these middle ones. And that's me got them made. Right, tell you what, now I've done that, let us gingerly, is this hot? The heat hasn't travelled too far back along it, so I shall unscrew this and put it to the side and open this. Now, what I was going to say there is that if you already have one of these devices with you, and it's important to note that this one is just a dumb one. It puts out 4.2 volts. Let's actually test that. It will put out whatever the battery voltage is. It doesn't have any sort of fancy electronic regulation. So let's just focus up to there. And I shall put this onto this connection here. I think these are more or less... Is it going to connect to the screw as well? That is not going to work. Hold on. Let me go on to that connection there then. 3.6 volts. The battery's probably about half voltage there, unless it's actually pulling it down with the... Well, there's no resistance on it as such. I did put this onto another unit. Well, let me do it, and I'll tell you right now. I'll just test this. This thing does claim to show the resistance. I'm not sure how accurate it is, but let's screw this in here and push the button. And it displays, I'm going to need a magnifying glass for this, it's tiny. 1.73 ohms it says. That sounds about right. I'll just leave that in there. This one is adjustable power. I'd be cautious that if this could theoretically boost the voltage up to drive this at much higher power, so I'm not sure really how far you could push it before it damaged the filament inside, actually overheated it. I think it might be better using it with the base unit. Or if you did use it, turn it down to something more appropriate, like maybe 10 watts, or experiment with it to see how it goes. But don't push it too hard, or it may actually damage the tip by overdriving it with too high voltage. Right, so let's open this up. And what I was going to say there was, if you put one of these, just one of these solder iron bits in this thing with a bit of solder wrapped around it on a key ring, or in your toolbox, then if you've already got one of these devices, then you could just actually keep this, and this would be your entire soldering iron. It could be quite useful. So I'm going to take the back off this first, just to see what's inside. Let's see if I can completely slip and destroy that lovely anodized aluminium finish. We'll see what circuitry's in here. Ugh. Is it going to come out? No, it's not going to come out. Is it an 18650, for instance? I think it may be an 18650. That's quite good. That also gives an option of upgrading it if you want to put a fatter lithium cell in. Well, it would be the same size, but you could put in a much higher capacity one. A proper cell. Let's see if I can get this out without shorting it out. Big button. Oh, there's a chip. There's a bank of MOSFETs. Oh, you know what? I think it's time to explore the circuit board. One moment, please. Picture taken, reverse engineering done, and it's been fully reassembled. So, the arrangement here, I'm just going to zoom down the circuit board. If you want to take a wee picture of this yourself, or a go at reverse engineering it, this section here is actually the other side of the circuit board, but the image has been flipped. That's why the text is all back to front. Just so that, say for instance, this pad correlates to this one, and this one correlates to this one. So the circuitry, I guess it's just a microcontroller programmed for a vapour device, but it's using a standard TC4056 battery charge chip, which communicates with the microcontroller to control the LEDs to show the charging state. Oddly, it has the option here. It's got 3 A19T MOSFETs in parallel, but it has the option to put a single package on the other side of the PCB. That is more or less it. Let me grab the schematic and show you it. Here is the schematic. I would tame this down, but you know, it's all going to go pear-shaped if I tame it down. I've tried to tame it down. It kind of went a bit pear-shaped. So there's the USB supply coming in. It's got a capacitor across it. Then there's a TC4056, which is the charge control chip. And the only thing in its immediate vicinity, other than, well, there's 2 resistors and a couple of capacitors in its vicinity. There's a 1.8K resistor that sets the charge current for the lithium cell here. And there's a 1K resistor, which enables the charge enable from the microcontroller. I'm not sure why they've done that. Maybe it's just to save battery life by turning it off, but it means the battery ever goes down too low and the microcontroller stops. It may prevent this from actually charging. There is another decoupling capacitor here. The battery itself, which is a 2,500 milliamp hour battery apparently. The microcontroller has a 10 ohm resistor and a capacitor to the 0 volt rail. To provide just basically a local reservoir, just so that if there's any spikes and glitches from the switching of the load, it provides a very simple filter to actually protect the microcontroller from that. There are positions for 5 LEDs, but only 4 blue LEDs are in place, and a 51 ohm resistor for them all, which is actually quite a low value. It means there's going to be quite a lot of current through those LEDs. Other things, there's the 3 connections over to the charge chip are the chip enable to enable it in the first place, and then there's the standby and charge. These are the 2 lines that tell it that it is actually charging the battery and when it's finished charging. The MOSFET here is a P-channel MOSFET, well, 3 P-channel MOSFETs in parallel. A19T equals A03401 to give it its full number. There's a 1K pull up resistor to keep it turned off, and then to turn it on, the chip pulls it down to the 0 volt rail via this 100 ohm resistor. There's also a sensor on the switch side that is normally pulled low, and it's got a 100 ohm resistor. I presume that when it turns it on, it's expecting to see this go high, If it doesn't see it going high, it indicates that there may actually be a short circuit across here, and the microcontroller will switch it off and just basically go into standby until the button is pressed again. It's just a safety precaution, I presume. I don't think it will monitor the voltage. I think it's just looking, well, it will effectively monitor the voltage, but it's effectively looking for a very decisive short circuit. I don't know if it's using an analog input in that. And that is it. It's not that complicated. I guess ultimately it's designed as a very basic vapour device, much like you might find in, well, in this. I was going to say its name there. Let's not say its name. Because YouTube does not like vapour devices being named. So that is it. I shall zoom back out. And indeed, I'll just brighten that image up again. Pow. So it's interesting. I wouldn't say it's an ideal soldering iron, but what it has in its favour is that you can easily carry these bits with you in a toolbox, and if you have a vapour device, then it does go in, and once you've mastered controlling it the correct switching, timing to actually get it up to a temperature without going completely ballistic, then it does have potential, and it can deal with quite significant sized solder joints, because particularly this unusually large chisel bit does have good thermal mass. But there we go. It's an interesting device. I don't think it'll ever really end up going back into this little hard case, because I guess ultimately some people will use it just as is, but I think many people would just use the bits as adapters in their existing devices like this. But as I said earlier, I'd recommend taming the power down so you don't burn out the element. I don't know if these things actually boost the voltage up for that. I've never really investigated this too deep. I don't know if it's got a little boost circuit. Now, in case you were wondering what that little circuit board was earlier, it was an adapter for converting micro USB to strings of LEDs. These little purple ones that came from One Below in the UK. And it's simply got two 10 ohm resistors, the USB connector and output connector. The reason for two 10 ohm resistors, it's featured in a different video, is that it spreads the dissipation, and it just basically limits the current to a sensible level, about 100 milliamps through the LEDs, and you can run quite long strings from a USB power bank or a USB power supply for a very long time, but not the ones that do the polarity switching flashing effects. So there we have it. I don't really know what this is called. It says Light 40. I don't know if that's actually what it is, or if that's just the other product for vapour. But it works, and I suppose ultimately for travel and stuff like that, it's actually quite useful.